So wonderful good morning, dear LinkedIn community, Composites Launch members and technical textile experts out there. I have now the honor today at the first day of the Textile Innovation Center with Karl at Obertshausen, their headquarters. This is the first hour of the Innovation Center, and together with me now is Jürgen. I met Jürgen at GEC just a couple of weeks ago, where we were talking about the Textile Innovation Center, and now it's here, finally.
Yeah, finally.
Finally it's here, finally it's open, and very clean environment, a lot of machine, and we will walk you through this. But I would like to start with Jürgen now about the technical textiles of Karl. As you know, Karl has different business units, warp preparation, for example, technical textile, and the third one,
warp knitting.
Warp knitting, yes. And we will walk through all of them, because you guys, you know, on my head there is composites and technical textiles, but of course we will be looking also around and widen the horizons for you guys. But we will talk about technical textiles first. So let's walk through this, Jürgen. We will start now immediately with carbon fiber, right? We are seeing a bonnet here.
Yeah. So, as mentioned, this is now our brand new Textile Innovation Center, and it shows the huge variety of warp knitting technologies. So, and of course, one is the world of technical textiles, and understanding warp knitting for technical textiles starts with understanding composites. So what we are producing are so-called non-crimp fabrics or multi-axial reinforcement. And I think
let's get this in the picture.
This is one of the most typical known some automotive application. You have in carbon fiber multi-axial, which can be used for structural parts, for lightweight, for of course sports application, to use it as, for example, this cover for the structural part of a high-performance car. But of course, that's not the one and only. So reinforcement means to save weight, to be on a lightweight level, to be sustainable. There can be other applications in automotive, can be, for example, be sandwich panels for some housing, can be something for caravanning, for example, can be pultruded parts, which can be used in under the floor for carrier, for batteries, for example. And it shows here what is the benefit of multi-axial reinforcement. For example, if you don't have reinforcement only in one direction, with a multi-axial fabric you are flexible to have fibers in different orientations. Typical plus minus 45 degrees, 90 degrees are the fibers in our non-crimp fabrics.
So the beauty of this bonnet is really that you see the structure of the carbon fiber, right?
Yeah.
So you have used a very thick tow here, as it looks like. Yeah. Is this by purpose or just to demonstrate?
To demonstrate.
Is a demonstrator, right?
As we know that, unfortunately, I would say, woven fabric is the typical for class A surface which you want to have visible, but with the multi-axial, and this is, I think, more and more also in the application, it shows a different structure, and you have more variety in playing with the fiber orientation of the carbon fibers, but also with the knitting yarn, with the warp knitting yarn inside. It can be colored, it can be red, can be white, so you can make different applications, and it makes it, I think, quite interesting also for visible parts in fiber reinforcement.
Absolutely, it gives you a totally different flavor.
Yeah, exactly.
So this is the rear of a seat?
Yeah.
Okay.
So of course we can also have in automotive applications grids, nets, which can be used for protection within the car, but can be also in airplanes, for example, everywhere where you need the impact protection from, for example, the interior of the carrier from the people. So Reinforcement is not also, only fiber reinforcement. Of course, you know, we have also applications, as you can see here in our next application area, so-called reinforcement in civil engineering, can be fiber reinforced concrete, but can be also, for example, for streets, for the reinforcement of streets, which is especially in our climate area. You know, we have always problems with our streets between winter and summer period. You have water within the concrete. You have then sometimes frozen period. Then you get problems with cracks inside of the concrete. Yeah, and for example, this can be such a reinforcement application you can use there.
Yeah. So it's quite stiff. Yeah.
Yeah.
So you have already some.
It's some coating on.
Coating on this.
Exactly.
Yeah.
So
it's not a matrix. It's a coating to get a better bond with the asphalt. Yeah.
Exactly. This is it. So this is then also, of course, sometimes a coating with asphalt already in the grid, and then you have, as you mentioned already, better bonding to the asphalt of the street.
And you got this is black carbon, or just the bonding is black, right?
Exactly. So
and
normally,
then you got also very lightweight and open structures.
Exactly. Now
so this looks more like a bio, is it?
Yeah, you are totally right. Yeah. This is flex, can be flex or even hemp fiber, and this brings us directly to the next application. Technical textiles also used for so-called vertical screening. Yeah, so you can use it as a structure for some plants wants to grow, and this can be used for vertical screening within cities to have better living quality, to have more green inside. And this is not a reinforcement anymore, but it's also a grid you can use for like civil engineering application.
So for our viewers, Jürgen, just walk us through. You got these three layers. So you got the soil, you got the stones, and then you got the asphalt.
Yeah.
Where exactly would you now place the reinforcement?
So the reinforcement is on the on the upper
third.
Yeah, upper third, 2 to 3 centimeters. Then you have asphalt within. You have in the upper layer,
where basically the load is the heaviest.
Exactly. It's especially where you have the highest bending. If there is some load on from a heavy car or a heavy truck.
And does it impact somehow the hardening of the asphalt? Does it foster it? So no impact at all?
Yeah, right. Of course, as we mentioned before, you need a good bonding between the textile and the asphalt. Yeah. If this is, then you have really a good reinforcement without any disadvantages.
Okay, and if you look here, you see also now below the stones. Now this is a different application, it looks like, right? Yeah. This is not the asphalt, this is now also the soil. So you are separating the soil from maybe the natural soil to the one that is functioning, right?
So this is a typical function you use in geotextiles if you want to reinforce some walls, if you have
to secure and sustain the foundation.
Yeah, if you have foundation, you need, for example, in water basins for different applications, even protect the shore on the sea, and you want to have like you say, a protection between water-based soil and dry soil. Yeah, so to help that you don't have any erosion in geo applications.
So just as a short wrap up, so we have seen the automotive industry, dear community, with the classical visible carbon parts. Now the astonishing part, it's not a woven fabric, it's a multiaxial in that case. And then we see a heavy construction infrastructure application here that can be done with technical textiles. So what do we have here now? Now what comes evident is we are moving now to defense applications, right?
Yeah.
So what is this about?
Yes, step by step we are going now from reinforcement warp-knitted textiles to, let's say, technical textiles for agriculture, as we had before already for landscape, architecture, even vertical screening. And we also have what often is not known. Typical application for warp knitting technology are fish nets, agriculture nets you need for harvesting. But unfortunately, we are living in a world at the moment which has some conflicts, military conflicts. The same nets also now used, for example, for protect streets from drones. So-called drone nets can be used to protect against military impact from drones. Yeah, this is unfortunately, but it's a useful application at the moment, which one-to-one is the same net you can use for this. Yeah.
So basically the rotors they catch into that fiber,
yeah.
And by that your drone becomes neutralized, right?
Exactly. So
as they say in the defense. You know, community, sometimes you always ask, why should a white fiber be colored in a color? Now I was Jürgen a couple of weeks ago at Diamond Aircraft in Wiener Neustadt, and I was seeing this engine there, and they had blue and red pipes, and I was asking the quality manager there, why is that blue and why is that red? I mean, it's common sense. Blue means cold,
yeah,
and red is hot medium. It could be hydraulic or water or something like that. So in that case, what came to my mind is, so in application where you have cold, you just use the blue one. Where you have hot, you use the red one. If you have something like sun, you use a yellow one and things like that. So it makes also sense for security reasons to color code textiles, yeah, and this is a very typical textile application in dyeing them in different colors. And,
exactly.
And many times critics say with technical textiles it's difficult to do, but as we can see, it's not so difficult. It's possible.
Yeah, of course. Normally you produce gray fabrics and then going to finishing, coloring, and depends on the fiber type, but the coloring is not a topic anymore. Yeah, so this.
All right. Then we continue with defense.
Yeah. So for protection, last but not least, you can use, of course, also not ultimately warp knitted, but can be warp knitted fabric for protection rests, where you can use aramid fibers, even ultra high molecular weight PE. So the inserts you insert in the vest is made from these fibers, and thus is a typical application.
Inside,
yeah. I mean, there is a standard, international standard for such protection inserts, and they have to withstand some impact velocity, some impact rate, and this often is made by aramid fibers or ultra high molecular weight PE, because it must be, on the one hand, it must be lightweight. It should be still have some flexibility for wearing, and of course it should protect you against the impact. Yeah?
I'm totally excited and enthusiastic because still my jacket holds this piece inside, so it covers basically my lungs and my heart. Basically.
Yeah.
Okay, cool.
So this is one of an application we are also.
And this is sealed, so you cannot open this.
Yeah, because the fibers must be protected against
be a problem.
Water and even also ultraviolet sunlight.
Yes.
Yeah.
So if need be, you can replace this.
Yeah.
Off you go. Yes.
Okay.
We have a trouser here.
Yeah. So this is then not the protection in its basic application, but of course we also have this for use producing camouflage optic with application in military.
Yeah. Jürgen, tell our community who is probably not so iterate on tricot machines, what is the speciality of a tricot?
Ilkay Özkisaoglu, creating sustainable value with Composites 360 on tour. Weekly on LinkedIn, YouTube and your preferred audio podcast app.
Jürgen, tell our community who is probably not so iterate on tricot machines, what is the speciality of a tricot?
A tricot machine is, how to say, the main application of warp knitting. So in the most applications we talked before, in multi-axial you use the warp knitting yarn for stitch bonding of the layers, but original warp knitting means to produce a tricot within system of warp yarn, where you have many single yarns you knit together. So this is the big difference to normal knitting. So in the warp knitting you have many single yarns within one needle chain, and you knit them together, and then you have a huge variety of how many of these warp knitting yarns you are using. We have normally 1, 2, 3, even 4 bar machines where we can produce such a fabric.
So Jürgen, thank you so much for the first impressions. So this area is called the Inspiration area?
Yeah, this is our textile showroom, where we show the world of application for warp knitting. So last but not least, one of our application is in health and medical application, which is a so-called cartridge for filtration, a filtration membrane made out of hollow fibers, and we can handle on our machines these hollow fibers to make a fabric. All the hollow fibers are then aligned parallel with a distinctive distance between each other, and so a gas or even blood can go through the fibers or along outside the fibers. It can be used for oxidation, to enrich blood with oxygen, even can be used for dialysis. And this application, then on the next step I will show you the machine.
So, community, Karl Mayr is not a producer of these garments. Karl Mayr is not the producer of the fabrics and the cloth, obviously. They're a machine producer, just to make that clear. And this Textile Innovation Center has a few machines, and also some are dedicated for technical textiles. And Jürgen, shall we have a walk around those machines?
Yes, by sure.
Okay, follow us. So, as you know, this was covering my breast and my lungs, and this is the Strike Force bulletproof. And as Jürgen knows, I'm always curious to know how these things basically start from the beginning. So, Jürgen, now we have dismantled this. This is actually sealed off to protect against UV light and water. Now, if we open this, now comes a very thick kind of material.
Exactly.
What's that about?
So this is now exactly what we can produce on our machines. These are a system of up to 70 layers of so-called ultra-high molecular weight PE fiber. So this is, you know, it is polypropylene, but a special polypropylene fiber with a PE fiber, polyethylene.
You said it's 17 layers?
70, up to 70
layers, 70, and one layer is about 10 grams per square meter?
20 grams.
20 grams,
yeah,
okay.
20 grams. It's
not bad, huh? My guess.
Yeah. It's a combination of high-strength polyethylene fibers in a so-called cross-ply laying sequence. So we have 90 degrees
okay. So
upon each other.
This is the length, vertical, and then the next layer is indeed horizontal.
Exactly.
Okay.
And there we have a combination of these fibers with some polymer matrix. It's a film. Sometimes the fibers are also coated with a special PE wax, for example. But the very beginning is the fiber coming from a creel. And as you can see, all the fibers are aligned in parallel, and with this lab machine here, we can, for customer tests, for customer sample production, we can spread these fibers to one really thin fiber layer, all fibers aligned in one direction. As you can see here, we have all the fibers in this single layer in one direction and coated by one side with a film or with such a PE wax.
Yeah. Just for context, one more time, this is a laboratory demonstrator machine.
Yeah.
We have seen these machines way bigger than this. This is just because this is the Textile Innovation Center, which you should come and see actually yourself. And certainly the configuration is flexible here. So you can adjust it and do things like this.
Yeah, exactly. So this is exactly what you mentioned. With this Textile Innovation Center, we just not show what can be done in the world of warp knitting, multi-axial laying and so on. But of course we invite our customers, come, see, get some ideas, some inspiration, and the next step can be, we want to test something new.
Yes.
And this is why we have also such laboratory scale machines here. Yeah? So, and we have here a modular system. We can spread the fibers, we can coat the fibers, we can of course then wind the fibers to make such samples. And the next step is then go to a prototype machine together with our customers, and then step by step go to the market. Yeah? This is of course what innovation makes and to bring it to the market. Yeah?
Now that may not now be your product here. Just for our converting community, I have here also a foil. As you know, we are also in the converting industry, roll good materials, and we will be there at the Hamburg Summit again soon. So this looks also like a PE foil. It's some sort of translucent. And then we have a foam type.
This is some a polymer foam. This is again for impact, energy absorption.
Okay, so the bullet comes here. Then this foil may be preventing this impacting the foam too much, and the foam basically dampens the movement further.
Exactly.
So that if the bullet comes, the person doesn't feel hurt.
Exactly,
also.
it sticks here, but it also against the trauma and the deformation. Yeah, exactly.
This is the size 200 by 300, and it's weighing 500 grams. It's not so heavy.
No.
Good,
this is why we use this very light fibers that you have also a wearability. It's not too heavy.
You
on
can
the one
move.
Hand. It's more flexible.
Do your job as a policeman or security officer, whatever.
Ilkay Özkisaoglu, creating sustainable value with Composites 360 on tour. Weekly on LinkedIn, YouTube, and your preferred audio podcast app.
So now let's dive into the machines of Karl Mayer, the technical textile machines. And this first part of the machine inspection with Jürgen is about also educating you guys. And because I also don't know, and I admit that I don't know everything about textile machines, get us on the fundamentals of the Raschel technique.
So what means Raschel technique? Normally our warp knitting machines have two different knitting heads we make for normal applications. This is a so-called tricot machine or tricot knitting head, or Raschel machine or Raschel head. And this is a special machine. This is a Raschel machine. Obviously you can see it how the take-up device takes the fabric out of the knitting head. So if it goes directly to the ground or goes 90 degrees under the take-up, then it's a so-called Raschel machine. And in the Raschel machine we have a knitting head with handling on the ground bar, the knitting yarn, and our special machine on the technical textile is a so-called Weft insertion machine. We have a second yarn system which is integrated behind the machine in 90 degree direction to the production direction. So it's perpendicular to the production, and we are using this Weft yarns to have aligned fibers and then stitch them together with our second or our first yarn system, which is the warp yarn. So
this machine is specifically done for medical applications?
It can be used exactly for medical applications. For example, it can handling hollow fibers, which can be used for filtration. Not only medical, it can be used for every filtration application where you have a hollow fiber, which is like a hollow fiber membrane. Inside goes something, outside around the fiber goes something, and you can, for example, enrich with gas or take some other substances out of the liquid. So this is a typical filtration application. So the specific topic on this machine is that we can really handle sensible fibers which have a sensitivity against tension. To hold, for example, the diameter, we can really handle fibers with a tension below 10 centinewton. And then we can really align the fibers, and the warp yarn also helps to hold the fibers on a different specific distance, yeah? And then we roll them to a fabric where we have only fibers, functional fibers perpendicular to product.
So, and particularly Raschel is for low modulus fibers?
Not particular.
Yeah.
On this machine, because it is a specific Raschel machine now. There is something on the knitting head which helps to reduce the tension during the knitting process.
Okay, so that's good to know that the modulus of these fibers also require different kinds of mechanical processes.
Exactly. Yeah. Because I think it's obviously that the understanding, if you have high tension on a fiber which has a defined diameter, especially if you have a hollow fiber where you want to go with a fluid through. So if you have too much tension, you have a elongation on the fiber, and this reduces the diameter, and so you minimize the volume, fluid volume which can go through. This you want to avoid.
So Jürgen, what would be a typical application now?
Yeah, as mentioned before, it can be used as a hollow fiber. In a hollow fiber membrane, many fibers are rolled and incorporated into a cartridge, which can be then here in such a cartridge. All fibers are aligned, and you can go with a medium through and outside of the fibers along.
And what is this cartridge for?
For dialysis, for enrichment of blood, for ECMO, for example, for
medical applications.
Medical applications.
Yeah. Okay, wonderful. All right. So what else can one? What is the investment of this machine?
Yeah, so the investment depends on the customer. How to say? Depends on the customer needs. I would say starting point of such a machine is around about 500,000 euro. Can go up to more or less 1 million.
Okay, so between 500,000 and 1 million euros invest.
Wide variety.
And I assume 20 years, no problem to use it.
So this is what Karl stands for, that if you have a machine, you can run
it's robust.
Yeah,
it's very robust machines.
Exactly.
What is the oldest machine you came across of Karl?
I would say it comes from the 1990s.
1990?
Yeah, 1990s.
1990s, yes. Okay, so 30 years old. Okay. Good. What else could you suggest to an investor who wants to invest in technical textiles? What would be a cool trend for this machine right now?
Yeah. Okay, how to say? We have global trends. Global trends are, we have demographical topic, we have ordering society. So medical is always a good investment, of course, but also we have these applications in, how to say, wastewater management, for example. Filtration can be also for wastewater, for drinking water. So we have an increase of welfare, and that we have global growth still in the citizens in growing countries, and this means you also have there a trend to increasingly support with filtration in this application. Can be also used, we discussed this with some customers, you can really integrate fine metal yarns for some conductive applications. So this is also a topic.
Like in the plane I saw in the carbon fiber, totally different weaving technology, of course, but you got the metal inside in order to get the
contacting or against lightning strikes.
Being put away. So there are some trendy markets out there, so dear community, have a look at it. So now we are in the Textile Innovation Center. Why did you decide to put this machine here?
Since this is especially here on the European market now a machine we have requests, and to put this machine here is to have this shown this development we made for the special development of the knitting head. This we have since, I would say, now 1 year, and there is now the aim to show this machine to the market. Because as you know, you can't go to other customers to show the machine for competitors of this customer.
Of course,
So, and all the machines normally, if a customer buys such a machine, it's running 24/7. In many applications. So we need this showroom here to show new machines, new developments that customers can come, can see what the machine can do, can test some new applications, fibers and so on. So this is why we, overall business units need such an application center, and the combination of showing the applications to the world of the customers, of our customers, which are the end user. This is also interesting to come in discussion with our customers on new markets, new business models. We can support them. We also have this inspiration hub, which is like a archive of our last 60 years of samples we ever made, which are all there, and you can see what maybe was made already 30 years ago.
Yeah.
Which forgotten in the society, and then, this was made some years ago. Yeah. So this is interesting.
Community, since I know Jürgen for quite a few years now, I have met you first time in Chemnitz. I know he's a brain, he's a very good engineer, and I like to challenge you. Are you okay with that?
Okay.
So the challenge is, I'm not from the medical industry, I'm from the filtration industry. Now explain our community once they come into the Textile Innovation Center. And I want you to show me this for filtration. How would you modify this machine in the Textile Innovation Center to make this demonstration work?
Yeah.
Money is no problem.
Okay, yeah. This always sounds good, yeah? If money is no problem.
Money is no problem. We say money is no problem for this purpose.
Yeah, then we can start really at a single fiber, because the fiber for the filtration is the functionality. Yeah? So, and the fiber can have diameter beginning, let's say, 100 micrometers, can be up to 1-2 millimeters. And to handling such different diameters means you have to start at the creel. We have to adapt the creel from the bobbin, then have to show how we can insert Weft insertion yarn in the transport chain, and then we have to talk what is the volume you want to go through with. What is your filtration productivity, how to say.
Okay, you mean the filtration media?
Yeah.
Okay.
Because then we can decide how many single fibers we want to have on a certain volume. Then we can talk about the pressure you want to integrate. What is the membrane material? It is polypropylene, can be different materials, and then we have to look how we can handle here inside. Because we have a huge variety of, for example, the density of yarns per centimeter. We can play with the knitting yarn. What should be the distance between the fibers? This is also what we can adapt. Then we have to talk about, should we at a certain frequency integrate another fiber, because we can handle different fibers in a typical periodic frequency of one yarn, then 23rd is other yarn, and so on. This we can also play with. Of course, color and normal variable is a topic. I think for this application, color is not so.
Could be,
but could
maybe
be.
Not. Yeah.
Exactly. And then maybe you afterwards want to cut in certain lengths. Then we can discuss what should be the cutting of your. The cutting length of your yarn you want to integrate in the cartridge, because the length of the cartridge gives the boundary condition on how many pieces we cut out of our fabric. And then we can also adapt the yarn, the warp yarn density, because we can adapt it to the cutting length of the length of your hollow fibers are integrated in the cartridge. So this is a huge field of a playground we can discuss.
So, first of all, you need a good interaction with your customers. Your customers' requirements must be rather clear. Or like the filtration performance you would require. And you would translate this then into a textile product. And once you have this textile product defined, you will go into the machine parameters. And you would start from the bobbin, really the creel, through the machine, and then winding it up to the size so that your output becomes what you require for your filtration cartridge, cassette, whatever is possible. So you would be really talking with your customer the whole chain through. From the product's performance he's requested to the make of the product.
So what we also have now in trend since some years, that our customers producing day and night fabrics. They often have no time to also show left and right what is a trend. So sometimes, especially also in the composite market, because then we only have a fabric coming out of our machines. You have many production steps afterwards until the end use. So often we also discuss with our customers the need for their customers, what could be a business case for our customers, to understand what could be other there. What can be done with the fabrics coming out of our machines.
You mean your customers sometimes have a blind spot and you help them cover those blind spots because of the big picture you're having on the market?
Exactly.
Clever, smart. Very smart, Jürgen.
Yeah, this is a topic you need, especially...
This makes you different also, right?
Yeah, especially in the competition to mass markets.
You see, community, we're talking here in Obertshausen. This is in Hessen. And this is in Germany, right?
Yeah.
So this is German machine industry in practice. Jürgen, fantastic. I'm really proud of you. Thank you so much.
Thank you for visiting us.
Yeah, I don't know how you would rate this, but this is a 10 of 10 consulting from you guys. Yeah. Thank you so much.
Thank you. We are happy to have you here. And this is why we have this Textile Innovation Center to show this, our world of warp knitting. Yeah.
Absolutely. How do we connect you with the stories within the composites and sustainable materials industry? We are on the ground to find the facts and we examine big innovative ideas. To this end, we have launched the Composites Launch Engineering Talks. What is the Composites Launch Engineering Talks? That is abbreviated by CLET. The CLET is an online format where we are streaming live on LinkedIn, YouTube, and recording the panels for your favorite podcast station. Within the CLET, we are giving you a slot and your seat in a panel where we are talking about the entire value chain within the composites industry, from raw material to the end use. We have raw materials, substrates, and components supplying to OEMs covered in that panel discussion. From our online studios in Germany, we cover events and corporates from France, Italy, UK, Central Europe, and many more European regions. Stay informed, stay connected, stay inspired. Join us for creating sustainable value.
With Composites 360 on tour, Composites Launch Engineering Talks, and Composites Launch End User Panels, hosted by Ilkay Özkisaoglu. Weekly on LinkedIn, YouTube, and your preferred podcasts.